Okay, so it's been a while that we've done video notes. So today we are going to do segments, arcs, and chords. So we're really going to start looking at all the properties of circles. All right, so first thing we're going to do, what are the definitions of lines and segments that intersect a circle? So we're going to find out what happens. Um, Identify special segments and lines. Use properties of tangents. Find arc measures, and remember an arc is just a piece of a circle. And we're going to use the chords of circles to find the lengths and arc measures. So it seems like a lot, but it's all very easy. All right, so first thing we're going to look at, what is a tangent line? So a tangent line is a line that intersects the circle in exactly one point. So a tangent line is a line that intersects, horrible, intersects the circle in exactly one point. So exactly one point. So for example, point A is the point of tangency. So it's where the point, where the line touches the circle. So a point of the point of tangency is the point where the line, or the tangent line, touches the circle. So for example, point A is a point of tangency, and we'll call this line L, and we'll say line L is my tangent line. A secant line is a line that touches the circle, and it intersects the circle in 2 points. So a secant line is a line that intersects the circle twice. So for example, 1, 2. So line EB would be a secant line. All right, so now a radius. So the radius starts at the center and goes to the edge. So SC and SD would both be a radius. If I wanted, I could draw a line to there. I could draw a line to here. I could draw a line to here. So I could create other radius as well. The diameter is the segment that goes through the center. So DC would be my diameter. And a chord is any line segment that touches the circle on 2 spots. So a chord has 2 endpoints on the circle. So has 2 endpoints on the circle. So for example, EB, the segment EB, not line. Line EB is a secant line. Segment EB is a chord. DC is a chord. So the diameter is a chord, but not all chords are diameters. So it has to touch the circle on 2 pieces. So if I wanted, I could create a chord over here. We could call this XY. So XY would be a chord, as long as it's touching the circle twice. All right, so let's identify. So name 2 radii. So go to the center and find 2 pieces that go to the edge. So AV, AF, and AB. So those are all segments. A chord, remember a chord has 2 endpoints on the circle. So EC is a chord, DF is a chord, and that's it. So those two are my chords. Oh, I could say segment ED. So segment ED is a chord. The diameter is DF. It's the chord that goes through the center. A secant line, remember it's a line that goes through the circle twice. So now I could say ED, but now it's line ED and not segment. A tangent line would be this line here. So again, we'll call this L because they didn't give it a name. So L is the tangent line, and the point of tangency is the point it touches. So B is my point of tangency. All right, so let's use some of this property. All right, so first of all, a tangent line. Since a tangent line, so they're saying line M. So this line here is tangent to the circle. It's tangent at point P. So basically, what they're saying is line M is tangent to circle Q if and only if M is perpendicular to P. So if you draw a radius to the point of tangency and you draw a tangent line through it, it will make a right angle. Therefore, if it makes a right angle, then you can create, guess what? Right triangles. And remember, we just had an entire chapter over what we know about right triangles. So don't forget those things. All right. So the measure of angle QPS is 90 degrees. All right, so if this is my radius and this is my tangent line, then this is a right angle. Well, if that's a right angle, then with these measurements, I need to see if this is true. So remember, to check if it's a right triangle, you use the Pythagorean theorem. So 12 squared plus 35 squared equals 37 squared. We need to check that this is true. So I do 12 squared plus 35 squared. So add that together in your calculator. I believe you get 1369. 37 squared is 1369. Therefore, this checks out. So yes, this is tangent. So therefore, ST is tangent. To circle P. Or we could say ST is perpendicular to PT. All right, so this one over here says in the diagram, point B is a point of tangency. So if this is my point of tangency, then this is 90. Remember, 90 degrees at the point of tangency. So that makes this side my C, this side is A, and this side is B. So we're going to do the Pythagorean theorem, yes, using the alphabet. So that gives me R squared plus 80 squared equals, well, what's the length of this whole side? If this piece is 50 and this piece is R, then the whole thing would be R plus 50. So now this is R plus 50 squared. So we've got R squared plus 6,400 equals, so now remember R plus 50 squared. R plus 50 means this. So we got to do R squared plus 50R plus 50R plus 2,500. First, outside, inside, last. Multiplication. These two are like terms. So I get R squared plus 100R plus 2,500. So solve for R. The R squareds are going to cancel out. Subtract 2,500 from both sides so that you have 100R left. So 6,400 minus 2,500 is 3,900. Divide by 100, and R is 39. Well, if my radius is 39, so if this is 39, then this is 39. So the whole thing would be 89. So find the radius. Well, there you go. R is 39 feet. So that's how you would do that. Be comfortable with it because you're going to see it more than once. All right. So now let's talk about the external tangent, congruence theorem. Basically, if you have a point that's sitting here outside and you draw a tangent line to this part of the circle and you draw another tangent line to this part of the circle, these two are equal. That's all it says. So RS is congruent to RT. So if R is my point, so RS is congruent to RT. Therefore, 28 is congruent to 3x plus 4. Plain and simple. Subtract 4, divide by 3. So you get 24 equals 3x. So x is 8. And that's pretty much how easy that one is. And this is always true. So think of it as a party hat. And you have a party hat on. The sides are equal to each other. Okay, here we're going to find arc measures. So the measure of the entire circle is 360 degrees, so all the way around. The measure of a semicircle is 180 degrees. The measure of the central angle, so the measure of angle ACB, so the measure of ACB is 50 degrees. Okay, so ACB is a central angle because the vertex is at the center. So the vertex is at the center. So that's what makes it a central angle, because the vertex is at the center. AB is a minor arc. So this AB, the curve, is a minor arc because it's less than 180 degrees. It's less than half the circle. The measure of the minor arc is the measure of its central angle. So it's the measure of its central angle. ADB, so if I go A around to D, then to B, that's a major arc because it's greater than half the circle, so it's greater than 180. And the measure of the major arc is 360 minus the minor arc. So if this is 50-degree angle, then this arc has the same measure. So it's also 50 degrees, which means the big one is 360 minus the minor arc, which makes it 310 degrees. And that's pretty much how it is. So whatever the measure of the angle is, the arc is the same. So they're the same measure. So however big it has to open up, that's how big the arc is. So let's look at some and let's see how we do. So it says identified as minor, major, or semi. So AB, so since this is a diameter, then I know this is half the circle. So AB is less than half, so AB is minor. And if this is 40, then this one here is going to be 140 because these two are half of a circle, which is 180. This is splitting it in half. This should be perpendicular, so that makes this 90. That makes this one 90. So this arc is also 90 degrees. And this should have a little arc symbol over it. These are all missing their arc symbols. I don't know what happened, but if you will, please put the arcs back on. So basically just put little eyebrows on them. All right, so ABC. So ABC is a semicircle. And a semicircle is 180 degrees. A to B all the way to D, that's all of this. Well, wouldn't that be 140 plus 40? Or you could do 360 minus 140. So this is major. So I'm going to look at it as half the circle plus a little more. So 180 plus 40 gives me 220. And then BC is this piece here, so that's minor. And it's 90 degrees also. All right, so now we got BAC. So let me erase some of these lines on here. I got too much. So A tells me where to go next, and then it tells me to go all the way around to C. So that's 360 minus 90. So this is major because it's more than half the circle. So major. So 360 minus 90 is 270. DAB, so D, A to B. So D to A to B. So D to A to B. So that's 140 plus 90. So that's major. So 140 plus 90 is 230. AD is this little piece here, so that's minor. Notice the majors are 3 letters and the minors are 2. The middle letter tells you the direction. The ends tell you, obviously, where to end. So AD, we said, was 140. CD is this little piece here, so that's minor. And it's 40 degrees. And it told me right here that AC was perpendicular. That's a writing. All right, it says in circle E above, tell whether, let's see, did it lose its arcs also? It says tell whether this arc is congruent to this arc, explain why or why not. All right, so ABC is this arc, and ADC is this arc. Yes, they are, because AC is the diameter. Okay, and then now we're looking at, it says find the value of this x. So let me move this down a little ways. All right, so we know there's 360 degrees all the way around. So that means that all the arcs, so AB, BC, so AB plus BC plus CD plus DA, they all have to add up to 360. So 5x plus 40 plus 70 plus 75 plus 2x has to add up to 360. So my x's, I got 2 and 5, so 7x. 7x plus 185 equals 360. 7x equals 175. X equals 25. So find the value of x, then find the measure of AB. So 5 times 25. So that makes this arc 125 degrees. This one would be 2 times 25, which is 50 plus 75. So this one is also 125. So these two arcs would be congruent to each other. All right, last part. There are some chords. Remember, chords are the segments that touch the ends of the circle or the edges. There are 3 theorems. Basically, if you're in the same circle or if you have multiple circles that are the same size, 2 minor arcs are congruent to each other if their chords are. So for example, this chord creates this arc. This chord creates this arc. So if this chord equals this chord, then this arc equals that arc. So arc AB is congruent to arc CD if and only if AB segment is congruent to segment CD. The next one says if the diameter or radius is perpendicular to a chord, so if this diameter is perpendicular to this chord, then it cuts it in half. So this is equal to this, and this is equal to this. So if EG is a diameter, and EG is perpendicular to DF, and this is supposed to be D, I don't know why I got checked off, then FH is congruent to HD, and arc FG is congruent to arc G. All right, so the converse is also true. So if you have pieces that are equal, then you'll also have a diameter that's perpendicular to a chord. And the next one is if you have the same circle or congruent circles. 2 chords are congruent if they're the same distance from the center. So that means that this chord is congruent to this chord if this piece is equal to this piece. So if EF is congruent to EG. So they have to be the same distance away from the center in order to get that. So let's put those properties to some use. So this should be our last piece. So using our chords. So find the measure of these arcs. And again, they lost their arcs, so put them back their eyeballs. All right, so they're telling me that this is 3.6. Well, this angle is congruent to this angle because they're vertical and they're 42 degrees, so that makes this 42 degrees. Well, if these two are 42, then this one's going to be 138 and 138, which makes this angle equal to this one, and so on. So you got your rectangle going on. Well, let's see. So arc WX, so this arc. So if you'll notice, this arc is created by this central angle. So if this central angle is 42, then it's 42. So remember, arcs are congruent to angles. ZY, so ZY is this one, so it's also congruent here, so it's also 42 degrees. Arc WZ would be this arc right here, which is created by this angle, which is 138. And this arc is also 138 because it's, so if this arc is equal to this arc, then this chord is equal to this chord. So this is 9.2. Let's see. I lied here. These should not be arcs. They don't have a little M in front of them. They actually want the length of these segments, so I apologize. So, like I said, if this arc is equal to this arc, then this chord is equal to this chord. So, and the same thing here. This chord will be equal to this chord because this arc equals this arc. So if you're basically two arcs equal, you have two chords that are equal. So you have to find those. So this is going to be 3.6 and this one is 9.2. So basically you have a rectangle. So you have some right angles, which means you can use Pythagorean theorem depending on what they're asking you to find. So let's look at this next one. It says find the measure of x. Well, I have a diameter, and I know it's a diameter because it goes to the center, and I'm seeing that it's perpendicular to this chord. So the rule says if a diameter is perpendicular to a chord, this is equal to this. So that means PT is congruent to TR. So 2x minus 4.1 is equal to x minus 0.5. So subtract x, I get x. Add 4.1 and I get 3.6. So that's all it asked me to do was to find x. Simple enough. As long as you're using the property right, shouldn't have any problem. This one says to find the radius. Well, I see that they're telling me that this is 20, and they're telling me that this is 20. And that theorem says if two chords are the same distance, then they are, or the same, sorry, if two chords are the same length, then they are the same distance from the center. So that means OY is equal to OZ. So that means 4x minus 5 is equal to x plus 4. Subtract x from both sides. Add 5 to both sides. And we get that x is 9. Now they want me to plug it in because it says to find the radius. So 9 plus 4 is 13. So that means this piece is 13. Well, think about it. That's not the radius because the radius extends all the way to the edge. So somehow I have to figure out that piece. Or I could just simply draw another radius. Because I know that this is perpendicular, so it cuts it in half. Well, if the whole thing's 20, that makes this piece 10, doesn't it? So this piece is 10. Well, this piece is 13. Well, isn't that a right triangle? So I have this right triangle where part of the chord is 10, the part we found is 13, so I can find the hypotenuse. So 13 squared plus 10 squared equals x squared. So 169 plus 100, 269 equals x squared. And we take the square root of both sides. And I guess we're going to go ahead and let's see, what did we do? What did that's 9. So that's x plus 4. It's 9 plus 4. 3x equals 3. I totally botched that up. 3x equals 3. So that's a 3, so that makes that a 7, which makes this a little bit different. So let me go back over here and fix that. So my mistake, this is a 7. So this is 7, and this is 7. This is cut in half, it's 10. That's still a radius. You can create your own radius from the center to any point that's given. So we know this radius is equal to that one. So we have 7 and 10. So 7 squared plus 10 squared. So 49 plus 100. It's 149. I hope you brought your eraser today. Take the square root of both sides, and we'll go ahead and just leave it as a decimal for now. And I believe that's 12.2. So x is 12.2, and it says find the radius. So we went ahead and found the radius to be 12.2. So this is 12.2, which means that if this piece is 7, that means this little piece sticking out would be 5.2, because the whole thing has to be 12.2 to be a radius from the center to the edge. So don't let things like that confuse you. Please refer back to your notes, and I will see y'all next time.